Break it down, how scientists separate mixtures, pages 12 through 23. Break it down to save lives. Blood is a mixture and different parts of blood do different things. Some parts of blood help fight off sickness, while other parts help make scabs so that cuts can stop bleeding. Plasma is the liquid part of blood. It lets blood flow through the body, and it has important proteins that help keep the blood healthy. Blood is a mixture. Sometimes a person who is sick or hurt needs extra plasma, which comes from blood that people have given to help others. To get the plasma from the blood that people have given, scientists must separate it from the other parts of the blood. Scientists use the properties of the different parts of blood to separate the mixture. Plasma has the property of being liquid at room temperature, while the other parts of blood are solid at room temperature. People give blood so that the plasma and other parts of the blood can be used to save lives. To separate blood, scientists use a machine called a centrifuge. A centrifuge separates the parts of blood by spinning the blood very fast. The centrifuge holds tubes of blood that are arranged in a circle. The centrifuge spins around fast, and this spinning separates the solid parts of the blood from the plasma. The solid parts end up farther from the center of the centrifuge, while the liquid plasma ends up closer to the center. The separated plasma can be used to help people who are sick or hurt. Separating the mixture can save lives. This is the centrifuge that separates blood into parts. The blood in this tube has been separated by a centrifuge. The plasma is the yellow part at the top. Centrifuge starts spinning, blood. Centrifuge finishes spinning, plasma, solid parts of the blood. This diagram shows how scientists separate blood by spinning it in a centrifuge. Scientists found a strange mixture inside ancient pots buried deep underground. Break it down to uncover the past. Breaking a mixture down can help scientists identify it. Scientists found ancient pots buried deep underground. Inside the pots was a brown mixture, which scientists thought might be food left over from a great feast in ancient times. They wanted to identify the mixture to learn about the foods people ate more than 2,700 years ago. The scientists could not use sight and smell to identify the mixture because the mixture was very old and it no longer looked and smelled the way it had when it was fresh. The scientists needed other kinds of evidence. They needed to find out what molecules the mixture was made of using something called gas chromatography. Like a centrifuge, gas chromatography uses the properties of different parts of a mixture to separate the mixture. Gas chromatography can separate the substances in a mixture by the size of their molecules. This is how gas chromatography works. Scientists take a little bit of a solid or liquid mixture and heat it up until it boils, making the mixture turn into a gas. The gas mixture is made up of molecules of different sizes. Scientists send this gas mixture through a tube of gel. Smaller molecules travel through the gel faster, and bigger molecules travel more slowly. This machine for gas chromatography. The scientist has opened the machine to show the thin tube of gel, which you can see looping in a circle just in front of her hand. Each kind of molecule will come out of this tube at a different time, depending on how fast it travels. This lets scientists study the molecules separately and identify each kind of molecule that was in the mixture. Identifying the molecules gives the scientists lots of evidence to help them explain what the mixture is. So here's the mixture of gas molecules being pushed into the tube. Long looping tube of gel. Smallest gas molecules come out first. So smallest, small, medium, large. This diagram shows how gas chromatography separates molecules by size. Using gas chromatography, scientists found evidence that the brown mixture they had been a rich stew. They were able to identify molecules that matched different foods. Their evidence showed that the stew was made of roasted goat meat, lentils, honey wine, and olive oil. People threw a party for the scientists based on what the scientists had found out. A cook made a meal like the ancient feast using all the foods the scientists had identified: meat, honey, lentils, olive oil. These photos show some of the food scientists identified in the brown mixture. Mixtures and properties. The properties of the substances in a mixture are the key to breaking it down. For example, scientists can often separate solids or liquids from gases because of differences in their properties. Those differences in properties are caused by the properties of the atoms and molecules that make up the substances. Molecular properties can also be used to separate substances from a mixture. For example, sometimes scientists can separate out a substance by the size or shape of its molecules. There are many other properties scientists can use to separate a mixture. Mixtures are all around us. Scientists study mixtures in living things, in outer space, and deep underground. To understand and use a mixture, scientists often have to break it down. Breaking it down can be hard, but also very important. How could you separate pollution from the air? Carbon dioxide molecule, nitrogen molecule, water molecule, oxygen molecule. Molecules from two types of pollutions. Air is a mixture of gases. At the top of this page are models of different kinds of molecules that are found in the air. The two molecules at the bottom of the page are kinds of air pollution, which is bad for living things. If you were a scientist trying to separate pollution molecules from the air, how might you do it? Can you think of properties you might use to separate the different substances in the air?